Okay, today's lecture, Lecture 8, will just get us ready for our geometry story problems, which will be Lecture 9. We'll do a very brief review of different perimeter, area, and volume formula that we will have. And the thing I want you to remember, perimeter, look at the perimeter formulas. Those are things that you would measure if you're just measuring around the outside of a shape. So think of measuring it with string. You're going to drag string around the outside of a shape. Area is something you'd measure by covering it with little square pieces of paper. Volume is something that you would measure maybe with like little cubes of sugar or shoe boxes, or basically you're just filling a volume up with cubes. Now to do this, as just a review, I want you to identify whether you'd need a perimeter or area or volume formula. So let's pretend that we're building a house. Now, some of these are a little ambiguous, but I'm just trying to keep it kind of real life because I think things make more sense that way. So I know that everything that I'm talking about has volume, but I want to think about what you would measure. Would you measure a perimeter? Would you measure an area? Or would you measure a volume to find out how much of the following you'd need? So if you wanted to find out how much string you would need to stake off around the hole to be dug, well, we'd measure a perimeter because we'd go around the outside of the foundation of the house. The amount of dirt dug out of the hole. Well, for that I'd measure a volume. I'd measure the volume of the basement. It would be a little bit more than that because you dig out a little bit extra, but I would measure a volume. The amount of cement used to pour the foundation. Now the cement has volume, but what would you actually measure? You could make an argument for either volume or area. The area argument would be that you would measure the area of each of the walls and the area of the floor, and then figure out the volume from there. The amount of brick used to cover the outside. Well, you'd measure the area of each of the walls on the outside, and that would tell you how much brick to get. The amount of shingles for the roof. Again, you'd measure an area of the roof. The amount of rain gutter. That goes around the outside, so you'd measure a perimeter. The amount of carpet. Okay, that goes along the area of the floor, so you'd measure an area. Crown molding. Crown molding goes around the edges of a room, so that would be a perimeter. How about tile? Tile, you would measure an area, the area of the floor or the walls where you're putting the tile. The amount of paint. This one throws a lot of people off because paint comes in gallon buckets, so you think volume. But what would you measure to know how much paint to use? You'd measure the area of your wall, so you would measure an area. The amount of salt to fill your water softener. Well, then how much salt you would need to fill your water softener, you'd need to know the volume of your water softener, so you'd measure a volume. How about the amount of insulation to be blown into the attic? Again, you'd measure the volume, how much attic space you have. The amount of granite for your countertops. Now I'm going to say area because that's what you're thinking it is, but when we built our house I realized they actually don't measure the area, they measure the perimeter. They go along the edges of the counter, so it's measured in linear feet. But anyway, for a math class we're going to say area. If you're actually building a house, it's perimeter. The amount of curbing for the landscaping. Okay, that would be a perimeter. Sod for the backyard, you'd measure the area where you want to put all the grass. The amount of mulch for the flower beds. Now, the mulch obviously is measured in volume just like paint, but you would measure an area. You'd measure the flower bed area, and then you'd figure out how deep you want the mulch to be. The amount of stone for the walkway would also be an area. The amount of fencing that goes around your yard, that would be a perimeter. So I hope that helps a little bit just to identify whether you're going to be looking for a perimeter, an area, or a volume formula to use in a story problem. Now let's see if we can answer some specific questions about this house. Let's say that the footprint of the house is 60 feet by 30 feet, and the foundation is 10 feet deep. We have water softeners. We have 2 of them. They're cylinders. The master bedroom, we'll say, is 12 feet by 15 feet, and the ceilings are 9 feet tall. And then we have a big window in the front that's 2 feet wide, and it has it's 2 feet wide and it has 4 feet tall, and it has a semicircle on top. We'll draw a picture of that later. So how much dirt was removed from the hole? Again, we know that it was volume. We know volume is equal to length times width times height if we look at our formula sheet. So we have 60 times 30 times 10 because our footprint's 60 by 30 and it's 10 feet deep. So that's 18,000. 18,000 what? Look at your units. It would be cubic feet. Volume is always measured in cubic units. How much crown molding was used in the master bedroom? Well, we know that the dimensions are 12 by 15 and it goes all around the outside. The perimeter of a rectangle is 2 times the length plus 2 times the width. So it's 2 times 12 plus 2 times 15. So we have 54. What are my units? Perimeter will just have single units. It's just linear units. So it's 54 feet of molding. How much carpet was used in the master bedroom? Okay, again, I'm going to be using my 12 and 15, but this time, instead of a perimeter, I'm not going around the edge. I'm filling up the whole floor with carpet. I'm looking at an area. So my area is length times width, which is 12 times 15, or 180. Now, what are my units? Okay, volume has cubic units, perimeter has linear units, and area has square units. So it's 180 square feet of carpet. Okay, here are some more questions. How much sheetrock was used in the master bedroom? Well, let's think of where the sheetrock goes. It's going to go on each of the 4 walls, and it's going to go on the ceiling. So we know my ceilings are 9 feet tall. So I have 2 12-foot walls by 9 feet and 2 15-foot wide walls that are 9 feet tall. And my ceiling is 12 by 15. So my ceiling's 12 by 15. Wall A, we could call it wall A, is 12 by 9. Wall B is 15 by 9. Wall C is 12 by 9, or another wall A, that's wall C. And then another wall would be 15 by 9. So I'd have all my sheetrock together. I'd have my ceiling plus each of my walls. So that would give me 666. What are my units? I was measuring area. So I have 666 square feet. I have square units per area of sheetrock. How much paint should I buy for the master bedroom if I need 2 coats? So here's a hint. 1 gallon of paint will cover 350 square feet. So I need 4 gallons, 2 gallons for each coat. Because if I have 666 square feet, I'd need 2 gallons for the first coat and 2 gallons for the next coat. How much salt would I need to fill the water softeners to a depth of 1.5 feet? Well, if I look at my water softeners, they're cylindrical, so look at the formula on the formula sheet for cylinders. They're 2 feet in diameter, but the formula doesn't use diameter, it uses radius. I know that volume is equal to pi r squared h. So if they're 2 feet in diameter, that means the radius is 1 foot, and I want to fill them to a depth of 1.5 feet, so my height is 1.5. Take 1.5 times pi. Now that's the right answer, but if you went down to the Home Depot and said, I need 1.5 pi cubic feet of salt, they would look at you crazy. So let's make it actually make sense. Instead of pi, put in 3.14. So my one water softener would take 4.7 cubic feet. Both my water softeners would take 9.4 cubic feet. Which would hold more? My 2 water softeners, or 1 water softener that is 3 feet in diameter. Well, let's look at our formula. Again, it's pi r squared h. This time I'm looking for just how much they will hold. I'm not worried about filling them to a depth of 1.5. I want to fill them all the way up. So for 1 water softener, I'd put in 1 for my radius and 6 for my height. So I'd get 6 pi, which is 18.84. So my 2 water softeners, if I filled them all the way to the very top, would hold 37.68 cubic feet of salt. Now let's look at another water softener that is just a little bit bigger in diameter. I think you may find this surprising. So I'd put in 1.5 for the radius. If it's 3 feet in diameter, that would put 1.5 in for the radius. Again, it's 6 feet tall. So I'd get 13.5 times pi, which is 42.39 cubic feet. So a 3-foot diameter softener holds more than my 2 2-foot water softeners. Keep this problem in mind when you work the problem in your homework about pizza, because just a little increase in the radius has more than a little increase in the volume or the area of something because we're squaring it. Okay, let's look at a couple others. Let's say my basement flooded until it was 4.5 feet up on the walls. How much water is there? Well, I'd have 60 by 30 because that's my footprint, and it's up 4.5. My volume is 8,100, and my units would be cubic feet. Very good. Volume has cubic units. How much molding is around this big window in the front? Well, let's look at it. There's my rectangle, and there's my glass. So if I were to go around the outside, the perimeter of that circle on top would be half the perimeter or circumference of a whole circle. So it would be half 2 pi r. Since it's 2 feet wide, the radius of the circle is 1. So my perimeter is just pi, which we will estimate as being 3.14. The perimeter of the blue part would be 4, and then 2 at the bottom, and then 4 up the other side, which would be 10. So the total perimeter is 13.14. So if I put molding around that window, I'd need 13.14 feet. How much glass is in the window? Well, my pink area would be half the area of a circle. So it would be half pi r squared. Again, I'm looking for area because I'm filling it in, not just going around the outside, which would be 1/2 times pi, or 1.57 approximately. The area of the blue is just length times width, which is 8. So I'd need 9.5 square feet of glass.